Hey guys, and welcome back to another video. And today we're going to be preparing some sodium pyrosulfate from some sodium bisulfate. Now, sodium pyrosulfate is a very useful chemical, and we're going to be using it to make some sulfur trioxide, and hopefully to try to make some nitric acid using an alternative method aside from the sulfuric acid method. Now, sodium bisulfate is sold as a pH lowering chemical and can be found at various pool chemical supply stores, such as Canadian Tire. That's where I got this here. You could buy about 3 kilograms of it for like $10 or $12 or something. It's insanely cheap. Now, this decomposition can actually be done in anything such as a toaster oven, and it's quite easy to do at home. Sodium bisulfate melts around 315 degrees Celsius and decomposes a little bit above that. However, the product form, sodium pyrosulfate, doesn't melt until 400 degrees Celsius, so this gives a really nice indicator of when the sodium bisulfate is actually fully decomposed. Basically, if you take your bisulfate, put it into a tray, heat it up, it'll first melt, and then as soon as everything's solidified, you know it's all decomposed in the sodium pyrosulfate, because I've found that these toaster ovens can't generally reach above 400 degrees Celsius. So, I weighed out approximately 800 grams of our sodium bisulfate here, and I'm just going to make a whole bunch of sodium pyrosulfate to do some experiments with and mess around with a bit of stuff. So this toaster oven I'm using here is of course only a lab toaster oven, and you shouldn't be using an oven that you'd use for other food, as you don't want to be eating sodium bisulfate or pyrosulfate. But I do find that these ovens can reach several hundred degrees Celsius, even though they say they max out at 500 degrees Fahrenheit. But this will definitely liquefy our sodium bisulfate, so it reaches at least 315 degrees Celsius. So I just use this pan here, put the sodium bisulfate in, and then we'll load it into the toaster oven. By turning the toaster oven onto high power for approximately 4 or 5 hours, full decomposition should occur. I did tape the switch, which normally is meant as the timer to time how long the oven remains on for, and I taped it in the on position permanently just so that it can actually stay on for those 4 or 5 hours straight. So you can see that it actually gets very red hot, and as this decomposition occurs, the sodium bisulfate is decomposing into sodium pyrosulfate and water. And you can see those small bubbles in there as water is slowly being released. This is a very slow decomposition at these temperatures. However, if you leave it for a while, it will fully occur. So once entirely decomposed, you can see that it's a hard, white, glassy, rock-like substance, so we're going to need to break it out of this pan. This is why I used an old baking pan specifically used for chemistry so that we can actually break it out. So I used the very scientific method of hitting it with a hammer to remove the sodium pyrosulfate, and after quickly breaking it up, I stored it in an airtight container, and we definitely want to limit its exposure to air at this point, as it will react with water to reform the sodium bisulfate. I then grabbed a blender, and this blender is strictly used for chemicals and stuff, and I ground it into a fine powder, and this will just make it easier to use for other reactions and whatnot. It is fairly hard and does take a bit of grinding to get it into a fine powder, but it does break up somewhat easily because it is a bit porous due to the decomposition releasing the water, which is of course decomposed as a gas, and this creates little bubbles in it. Anyhow, so after grinding it all and everything, we have several hundred grams of our powder here, and before using it for any other applications, I would recommend just drying the powder in an oven again, just because it will absorb moisture out of the air. Thus, it is also important to keep it in an airtight container to limit that reaction forming the sodium bisulfate again. Anyhow, as I mentioned, we're going to be using this to make some sulfur trioxide, and maybe use it in some other reactions such as making some nitric acid. So, hope you guys stay tuned for that, and I hope you enjoyed this video. Anyhow, I'll see you in another project, and I'll talk to you guys later. Okay, bye.